So coming to the last class that we have seen onto the Plaxis viewer side, what are all the different options that we have it to see the results and all. So those particular options that we have seen. And next we will move on to the next level, that is like the consolidation analysis. Anybody has tried it, the consolidation analysis that we discussed?
Yeah, I have tried, but it shows the soil body is collapsing always.
Okay, fine, that's good. Yeah, I can guess one particular problem that you might have done a very small mistake that may or may not be, but I just need to look into that. Maybe I'll just take you to that particular thing. So if you're doing that particular same mistake, I think we can able to rectify those particular things also. Okay. So while doing this thing, let me take to the screen. Yeah. So I'm just sharing my screen. Let me know once if you can able to read this. You guys can able to see my screen. Hope you can see my screen. I'm just proceeding.
Yeah, yeah. Good.
Okay, moving on to this. Actually, what I'm doing here is like I'm just taking up a soil, and to this particular soil, I've just created one particular borehole. And if I would like to see into the borehole, I have just collected it as only a one particular clay layer, and the depth I'm just considering it as a -6, and the water level is exactly at 0. So to the groundwater level actually equals the water level is at exactly on the top surface of it. And now when you just look into the material properties actually, so here the material properties for the clay layer okay, the material properties for the clay layer that what we have taken here is like into the clay layer, we are selecting this as a hardening soil actually. So when you are selecting it as a hardening soil under the drained model is again like a, you know that the drained model is nothing but your long-term material behaviors. Okay. And then you're providing the saturated and unsaturated weights over here. And to the parameters, you have to provide your odometer test results and all. Okay. It's mean that they can be called it as multiple times, like you are excavating something and after that you found that particular soil, that you can treat it as a hardening soil, or like at the starting itself you can consider that as a hardening soil by assuming that, and then you can start working on it. Okay, this is all up to the level that what you are doing it in the realistic world. That's all of your choice. Okay, so you have to understand that particular things and then you have to project it further here. By default, at the starting level itself, I'm assuming this as a hardening soil. So there might be some activities performed it in the past that I'm not sure. Maybe by considering that particular past activities, I'm just considering this as a hardening soil also. Okay. And then after putting up this particular things as a clay layer, okay, I'm just moving on to the structures module. Now into this particular structures module, there is an option called as an see create a soil polygon actually. So using this particular soil polygon, you can just start creating this whatever you want. So go to snap object. So to the profile that whatever you wanted, you can able to draw like this. Okay. So like this, here I have just drawn particular profile as per the geometries, and the profile it looks like this. If you want, you have a control of like the entire profile for each and every points, point 0, point 1, point 2, point 3, and then the point 3. So 1, 2, 3, and then you are just closing this particular thing. Okay, so like this, you can able to create this particular polygon. And on this particular polygon, actually, I've just assigned one particular material. In this particular material properties, I'm just considering it as an embankment. Okay. So this particular material properties, I'm calling it as an embankment. So what are the embankment material properties I'm considering? Here I'm considering again that as a hardening soil itself, because which is already an excavated soil. That particular soil I'm just bringing and then putting it over here, which is an hard in nature. So I will consider this as a hardening soil, and then the saturated and unsaturated weights of it, and then the odometer test results. I'm just passing it over here. Okay. So now after doing up all these particular things, this is what is actually the structure that I have built it. Now I'm just going for the mesh. So simply you can just generate this particular meshes. Okay, here I'm just selecting it as a fine mesh, so you can just simply select it as a fine mesh. And if you would like to visualize the mesh, you can just click on this view mesh, and then you can just continue. Okay, here you can able to see the measures of all these things. Yeah, and now after doing this, you can just go for this particular flow conditions and make sure that the water level is also at the zero. Yeah, that's true. Now moving on to the stage construction, this is where actually I'm doing it. Now in the stage constructions, that what you have to remember is like, you have to remember this, the initial phase. This is what actually, do I need to consider this as a gravity loading, or do I need to consider this as a KO procedure? So the first thing is actually, so this is a KO procedure because I'm not considering the embankment during my start of the construction. So I just consider this as a KO procedure, and to the pneumatic water level, the water level is also up to like pneumatic conditions only. And now to this particular initial phase, I'm just creating input as an initial phase. I'm doing some condition with construction drain conditions actually. So now actually, if you see this particular thing, so the analysis here, I'm just doing it as something like this. I'm doing an initial phase and I'm building this particular thing. So, okay. And I'm building this particular embankment, I'm constructing it. So that's the reason I just put this as a plastic calculations only. And I'm just giving okay. After constructing this particular part, again, I'll do one particular safety analysis. Now, after doing particular safety analysis, I may reach up to some particular value, like this construction is how stable it was. Okay. This, how stable it was, like immediately after the construction, I'm just validating it. But this is an initial phase, and I'm just going for this conditions with the undrained conditions and all. So now the bottom soil layer before I have selected is there's like a drain conditions. Now by keeping this, if I just go it as an undrained conditions, what will happen actually? That is what actually I'm just trying to see these things. Yeah, undrained conditions to the parameters. You can just go and feed this particular undrained A conditions for the hardening soil itself. So this is one of the another best example that you can see that when I was executing my problem with hardening soil as a soil model with the drain conditions, with undrained conditions, with the same embankment material properties, what is the factor of safety it is going to be changed, that we can able to identify those particular things. Yeah, till this actually this is fine. But here in this particular problem, they have not covered up any kind of a consolidations. That if you would like to consider for the consolidations also, there is an approach. That's where like after this particular construction, that you can add one more phase. You can add one more phase, and to these particular phases, you can just name this as a consolidation under drained conditions. You can consider this as a consolidation under the drained conditions, and then just give okay for this. Sorry, here you have to choose, instead of plastic, you can just choose this as a consolidation analysis. Once if you just choose this particular consolidation analysis, like you would like to wait for this. What is the, this is a stage construction. That means you are providing the number of a days for the consolidation, or it is a minimum excess pore pressure conditions, or the degrees of consolidation. There are three options in that. So the first one is like a stage constructions. That means like when you just selected the stage constructions, you can define it. I would like to consolidate for 10 days and then I wanted to see what is happening for this. Okay. The other way is like when you just go for the minimum excess pore pressure conditions, and just simply providing this pore pressure calculation type when it reaches to a minimum condition. That is, when your pore pressure is considered, when your pore pressure is reaching to up to like 1 kilonewton per meter square, then automatically the solution says that it is converged and it will stop it. So here, as an output, it is going to show the number of days it required to maintain your minimum pore pressure conditions. And all. If you have like a degrees of consolidations, then you can able to treat it, whether you want to make it like a 90% consolidation, 80% consolidation, or 95% consolidation. You can able to choose it on your requirements and all. Let's say this here, I would like to go for a minimum pore pressure conditions, and I'm not providing any number of days. See, these days are like a dummy days only, it is not valid. So previously I just entered it as like a 10 days, that's why it is showing. But if I just put it as 0, that doesn't matter actually. When you select this minimum per pressure condition, so only this particular value is required. Okay. Now just giving okay. For this particular consolidation stage, the construction stage should not is the input for this. Okay, fine. Now the safety factor drained analysis. So for this, the input phase, it is like from the consolidation actually. So just give okay. Now see this one. You have an initial condition. See the image is also changing over here. Then you are putting up this soil polygon, and then you are assigning this particular material properties like set material, embankment material properties, and then you are doing this consolidations with a minimum pore pressure conditions that which will reach us to a 1 kilonewton per meter square as a pore pressure. After that, after reaching that, again you are validating your it's a factor of safety. Okay, this makes you a lot of difference. When you just constructed this without any consolidations, you are doing a factor of safety and did previously, but now actually you are constructing it, you're waiting for the consolidation, and then you are doing the safety analysis also. So this shows you like a lot of difference between this. Okay, now let's try to solve this particular things. So I'm not solving these two as of now. I will just follow only these particular things. Let's see this. So the initial phase it was done and the construction is also successfully done. Now it's going for consolidation. Consolidation also it reaches it. How many days it took that actually it will display it over here, but it was a very short interval. I could not able to show you that. Here you can able to see this days and time actually. Okay. How many days it may take will show you that. But here it is now it's calculating the safety analysis. Now we'll see that. Okay. Now with this, if I just go, the factor of safety it is showing me something around like 1.8 actually. You can see this here 1.8. Okay. Let's do this. I'm not doing any. Okay. Let's do the consolidation also. When you just go for this consolidation analysis, you cannot see the values like how many days or something and all taken it over here. Reach total time like it's always showing it as like a 0 days. Okay, but just to show the better values, you can just go for this view calculations. And the view calculations, if you just go here, this is my initial phase. And in the initial phase, after this, I have done some kind of a construction. So during this particular constructions, there is a deflection. I mean, there is a settlement happened of like a 0.22 meters of settlement it got happened it. And after that, I'll just click on this consolidation. Now, if I just click on the consolidation, the time taken to reach to the minimum pore pressure conditions was something like 0.1 10 to the power of minus 9 days. So you can convert this particular days into your seconds and minutes. So for this particular problem, you no need to wait for the consolidations because of its hardening soil in nature, which is already in drain conditions too as well. Okay, but here you can able to see that number of days and all. So whatever you want, you can just see this particular number of days over here. Okay, and if you would like to see the safety analysis, this is how actually it shows us. So the in the safety analysis, if you see, don't see the displacements at all because 1545 meters is a never be a displacement. It can never be a settlement actually. It is an earthquake kind of thing. Okay, I can say more than that too as well. Okay, so now if you just, so this is a dummy displacement. As I already told you that in the factor of safety, we need some supporting axis. So here displacement will take as a supporting axis and the values that we are going to get the output is like a dummy one. And now here it shows you like whatever the deformation you can see here, this the deformation is showing that there is a sliding in nature actually. So this particular sliding in nature says that this is the critical region of your part. This is the critical region of your design is what it is showing it here. So that's how like you can able to calibrate it. Now this is 1.8, right? The safety analysis. Let me do for these two particular problems. Let's if I solve these two particular things. Hey, just give me a second, guys. Hey, I'm sorry, guys. That was from my kid actually. Okay, fine. Moving back here. So I'm just trying to solve the other cases where the constructions with undrained A conditions of the soil, and then I'm trying to identify the safety factor here. And let's say that don't compare that safety factor with this particular safety factor, because actually here we are doing the consolidations and then doing the safety analysis. Here without doing any kind of consolidations, that we were trying to do the safety analysis. Okay. Here though, in the first case, the consolidation contributions was like very, very less actually, because within no time it is reaching to a minimum pore pressure conditions. But now that may not be the same scenario when it is reaches to an undrained A conditions, because what happens in undrained A conditions, above the groundwater level also, there is a calculations of a pore pressures calculations is happening, right? So as we all studied about this, undrained A is like again a short-term material behavior where it needs your strength and stiffness material properties as an effective material properties, and along with that it will consider an extra mass above the pneumatic level, that which calculates the excess pore pressure conditions and all. So now, because of that particular excess pore pressure conditions are considered above the groundwater level also, the behavior is completely going to change. So that's the reason actually it's taking you a lot of time. This is one of the best examples from Blacksys to know about the difference between a drained and undrained models. Okay, let's wait for this. And I'm not doing any consolidation again here. I'll just come back. We will see the factor of safety first, and then we will go to the consolidations of the same thing again. Consolidation is very easy. You just have to choose it, and there are like three different conditions in the consolidations that you just need to follow up this. And let me bring up. Okay, sorry. I might have covered this consolidation. Let's just to mark for the dry condition. Yeah, this is actually the slide that can help you out. Uh, this particular presentation, it is already there in the wiki and it's already there with you also, guys. Okay. So in the consolidation analysis, if you just consider that there are only three cases where you can just go for a stage construction. So the stage constructions, there is a no control on your pore pressures. And if you just go for the minimum excess pore pressure conditions as a technique, there you can able to pass on your pore pressures that which need to be reached over. So the minimum excess pore pressure, user can control the pore pressures value to be reached. And the degree of consolidations, you can pass up your own particular consolidations also. Okay, this slide will help you out to understand what is a consolidation analysis and in what cases actually it will help you a lot actually. Okay, and the safety analysis is also this actually. It calculates you the safety factor by keeping that like x maximum available divided by the s needed for the equilibrium conditions and all. So based upon these two, actually the factor of safety it is going to calculate. So this is one of your questions, Vivek, how it is going to consider the bearing capacity. So from the factor of safety, you can just able to calculate it, and from there you can consider your bearing capacity of it. Just if you know that it is like 1.8 is your factor of safety, that means your maximum loading capacity that you applied is something 100 kilonewtons. And if it is like a 1.8, that is like it can able to bear up to like 180 kilonewtons. That is nothing but your capacity, final capacity. Okay. So now the incremental multiplier here actually sigma MSF, it calculates a safety factor based upon the least consideration factor actually. Okay. So in the loading type, it is an incremental multiplier, but in the loading type, if it is like a target MSF, it is like a 1. So it calculates a safety factor based upon the input value given. This is what actually we already covered it. And the other one that I would like to come and tell you is like sigma MSF value, that incremental multiplier. Instead of target MSF, incremental multiplier, I can say that. So this incremental multiplier, it calculates a safety factor based upon the least considerations. That is the best value that you are going to get it. In the critical analysis only you can do that. Okay. Now you can see this. There is not enough load steps to run this particular problem. Okay. So what do you mean by this? There is a no enough steps to run this particular problem. This is an error code of 102. And here, if you can see this, this is just a warning, guys. It is not a red color. So there is a no error, but this is just a warning. And this particular warning says that uh, it is not enough load steps to carry out that particular analysis is what it is saying that actually. So, and now in this particular things, maximum number of cores that we are using is like 246 and use default parameters that we are using it, right? So let's say that you can just cut off this one so that you have a capacity to enter up all these particular things. Now, previously, I'm just going for 1000 steps, right? Let's increase to 10,000 steps. If you just click on this by mistake also, it is going to come it as 1000 steps. But if you just unclick and then you can just enter this 10,000 steps and then just give OK. And now you just try to solve this particular problem. This is quite important, maybe a time consuming process, but this is a permanent error that you can also resolve it. Now, if you see this particular thing is actually previously the maximum number of steps actually it has been taken up to like 1,100 steps. And now I've just given it as something like a 10,000 steps and all. It has been reached up to like 10. Wait, come on. 100 steps also it is not working fine. Why? Maximum number of steps to be stored. This is the default. Max number of steps is something like 1,000. Let me do one thing. And the safety it's also got calculated this, but this is like a warning step. Let's see the safety analysis for this. So now it's like 1.3 is the thing, but this is not an error. This is just gives you a warning. And this particular warning, if you would like to edit this particular warning too as well. Yeah. Now steps right. Let me resolve this once. Let me look into this. Now, see, previously it was taken up to like 1,000. I don't know why. Now it is being changed to 10,000. So in the recording video also, you can just go back and check that. So, and now previously it was reaching up to like 100 and then it was failing it. Now, the current steps, it should go beyond 100 and then it need to try to solve this particular problem with this. Okay, so previously it was reaching up to like 100 and then it was about to close the saying that it's not an error, I can say that, but it doesn't have a maximum number of steps to converse this particular problem fully. Now I have like around some 10,000 steps to converse this particular problem. So slowly it is increasing this. So this is where actually a Newton-Raphson method or a quasi-Newton method that you are trying to solve it. The small number of steps it has been considered to solve this particular entire problem. It has been reached to the number of steps that you consider, but still it could not able to achieve the solution is what it is meant. So to make sure that to achieve the solutions that you are like increasing the number of steps actually. So that's where you can see this, the maximum number of steps value. Previously it was 100. Now I have just increased to a more number. Okay, sometimes it may not satisfy with 1,000 steps also. In that particular case, you have to see that you should not increase the number, but you have to see, understand what is the problem, why it is happening like this. Is it realistic that I'm solving it or not? So you have to consider up all these things. It will generate some results. If you could not able to understand anything, go to the results, observe the results so that you will get some conclusions over there. But it may be a time taking process that you need to spend some time and understand those particular processes. And moreover, here you can see that there is a decomposition. It is, you can see one factor. Okay. So the decomposition, it says that like it's 100% decomposed. That means actually 100% it is good. When it is decomposing, That means the material is 100% good quality, and if the material is getting failed or something at that particular point of time, it will lose its quality of those particular materials and all. Okay, so that's what actually you can see this. And the tolerance, actually here the tolerance, it's going around like 0.01 is the tolerance, and in which element actually it is solving it at 391 element is the critical time. So if you're just observing it and the way and the analysis is struck for a very longer periods of a time at a particular element numbers, that is your main element number that you need to monitor in your results window. Okay, now here I see that it's been struck for a longer period of a time at 391, that there is something critical things are happening at 391. So now during that particular results, I just need to make a note of this 391. I have to go back and then need to study that what is happening over there. So still the element is not at collapsed it, or it is not at, so it is taking up the load actually. 391 is taking up the load. So that's the reason still like you can see that the problem is going up. Now it's almost like 678 steps and all it is going on. And now it has been reaches up to like 0.8485. So the main idea of this is like when you just end up with some kind of a warning that it says that not enough number of steps, then actually what you have to do, you have to come back here and then you have to look into that particular error, and the error code is always 102. Okay, so if it is like a 102, then come back and change at that particular step alone, you can change the maximum number of steps to some 1,000 steps or something, and then you can just solve for this particular thing. Okay, now in my observation of all these particular things, I'm almost solving there to some 1,000 steps, and I see that the criticality is happening at 391. So first thing I need to understand it where this particular 391 is coming, my element 391 is coming, and then how I would like to say, okay, so what's happening over there, and then I just need to check up the criticalities on that particular things, and then need to make some decisions. Yeah, now we will see that on the results also. I'll help you out like how to visualize a particular element number of 391, and then we can see that there is some good options and bad options in the Flaxus viewer, but we will stick on to this. Now you can see this, guys. It could able to solve this particular problem, and you can able to see in the green tick mark itself. And then after this, if you would like to solve this safety factor, previously the safety factor is 1.391, but now also it was almost all maybe the same, or it may come very nearer to that only, because the Flaxus is having a capacity to understand the previous step is an error or a warning. So if it is an error, then it is going to be an estimate the results, and then it's going to show you this particular thing. Let's see that what is the factor of safety coming it over here. If that is that much critical, then it's going to change. Otherwise, it's going to stick on like see 1.391. So that means your factor of safety is telling that the previous step, you no need to spend some particular amount of a time, though it's giving you the warning, but the sufficient amount of calculations is already considered by the software. That is what actually the information it's going to tell you those things. Yeah. Now this construction it is done. Now maybe you can just add a one more phase, and this particular phase you can just say it's again a consolidation analysis. And now in the consolidation analysis, again, you can just consider it as a minimum excess power pressure conditions. Just give okay. And this particular safety factor input is nothing but your physics. Okay, so now I would like to solve this too. So now I can do an apple to apple comparison, that is like with the drained and undrained A conditions, what is happening that I can able to see here. Now see this guys actually here you can just able to watch all these things how actually the time it is taking up. So this is the maximum number of days actually it is taking up this particular thing. I mean, at the time in terms of like seconds that you have just provided it, it is going to take that particular seconds and then it's going to give you as an output results and all. So to reach up to a minimum, this is where like the pressure you can see here, it is like 47, and then that particular thing it could not able to solve this. And you can just look for this particular calculation too as well. It's where like again it's number of steps is not sufficient for this actually. So you can just see the behavior you have seen by selecting up a drained conditions and undrained A conditions. Why considering this an undrained A conditions, why you are facing so many problems is like it's always going to consider the excess pore pressure conditions. This is where that you should have some good enough of intelligence to understand that. So the prescribed minimum excess pore pressure is not reached. That is like a one, it is not reached at all. It has been stopped at somewhere else like a 47 or 48 like that. Okay, so you can just start increasing the number of steps and you can do that. But you have to understand data whether really we need the pore pressure conditions onto the embankment in realistically that is makes sense. If it makes sense for you, then you can use this as an undrained A conditions. No, if it's not required, then stick on to a drain conditions. So the main intention about this particular problem is like when to select a drain and when to select an undrained A conditions with a better examples. And to this, I added, apart from the tutorial, I have just added a consolidation also into this particular picture over there. But this is just to know the stability of your embankment and the factor of safety values. Okay. So if you just go for this particular results here, okay, this is your final stage where the factor of safety it has been reached up to this particular level. This is the, yeah, this is the final thing. And if you just look into this, if it is like a drained condition, I mean to say, sorry, undrained conditions, it is deforming around like a zero point 0.6 meters. But if you just go for it as like a constructions for a drained condition, it is deforming around zero point 0.2 meters. You have seen this because when your pore pressures calculations are happening above the groundwater levels, automatically though it is a hardening soil, you're weakening the soil because of like it's having a relief to pass on this particular pore pressures inside. And because of these particular pore pressures, actually the soil may not get up a high compressed in nature, and it is not, molecules are not near to them here, like the crystals are not in so good contact. So that's the reason actually you may lose the stability. And for this, this is the best example that you have seen. So in this case, we have seen this bunch. And when you just go for this particular phase 6, that which is there, you see the deformation is around like zero point 0.6 meters and all. Now in this particular things, 391 is the problem that which is causing your biggest things and all. Okay. So 391 is being one of the problem. Uh, yeah, this is a thing where if it is like what is happening at 391, that if you would like to see for all these particular things and all, you have to zoom in, you have to identify it where this particular number it is located. So 391, where exactly it is located, it's a hard for you to identify that particular things and all. But okay, 391 is one particular element calculations. I was keep looking into that, but it was but this is somewhere else over here itself. That is what I can able to understand it. Okay, so if I could not able to get this particular thing idea very clearly, uh, we just do one thing. Oh, okay, we can just do one thing over here. You can just click on this particular table. Now this particular table gives you like what is the node number and what is the element number actually. So in this particular things, we can just simply go over here. This is where like element 290, element 358, element 391. This is the last element that we have it. So what is happening in this particular element? It is a 15 noded element. Each node is behaving it like that. I mean, this is the local numbers, and this is the node numbers. And in each node, what is the coordinates of an x, y, and z, and x, y coordinates, and then what is the deformations in x and y, and what is the total deformations it is happening over here. Okay, this is how actually you can just able to plot this particular things. But normally in industries, there is an options that we will provide it. Maybe not in our license, but there is an option that we will provide saying that we can pick the element actually, the selected element, we can pick it up and then we can able to plot this particular results. But how to do that in this particular version, I'm not sure. Let me check that. I will park this question and then I will let you know by the next class. Is that possible by enabling some backend options or not? I need to verify that and then do that. But this is very simple that there is one pop-up window. You need to pass on your element number so that it will appear it over here. That's possible or not, I'll just tell you that. That thing. Yeah. Yeah, Bharat.
Hello.
Yeah, Bharat. Tell me.
That embankment load, can I apply in various stages?
Yes, you can do that too as well. So it's very
In that
simple.
case, the ultimate deformation will be low.
Slightly varying.
Ah, yeah.
Slightly vary. Not too
Yes.
much, but slightly it will vary.
Okay.
That depends upon your site actually. So in the site, how they are doing it, they are doing some 50% one day and 50% another day. Then you have to go in the same way. But they are to putting it in the same day, then you have to go it in the same dates. Because what happens, when you are going for this particular day by day wise of constructions also, the stability, the software is having a capacity to understand that particular stability also. So that's why you can able to see the slight variations. Even reality also, because of some natural consolidation, it happens. It will gain more stability, and then that's the reason the deformations would be like little low.
Yeah. The time taken for consolidation also increases.
Yes.
Okay, okay, bro.
Okay, so this is how actually you can just start playing up this, and then you already know this particular thing consolidations well. Yeah. Now moving on to the safety analysis. Now you have done this as like an incremental multiplier. Suppose if I just put it as a target sum SF. Okay, previously it was reached around like 1.391. So now I'm just reaching up to this target sum SF. So now if you just see these things, you won't see any much difference actually. The first one. Safety factor under phase 4. What is phase 4? Yeah, this is the phase 4.
Increase to
Safety calibration for that is the target
1.475.
minimum semester for value is too low. The target value must be greater than 1. Okay, 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 fine, fine. Maybe just put it as like a 1.2. That is where is your target factor of safety. You can consider that I would like to achieve this particular problem. I mean, in all the cases, like you are solving the problem, but in this particular case, let's say that I would like to say that my target factor of safety is like around 1.8. So just give that particular 1.8 and check whether you can able to reach to that particular value or not. Now it is solving it. If it is not able to reach to that particular 1.8 value, it will say that, okay, I can't reach it. If it can able to reach it, then it will show that. See, it is throwing you a warning because If it is not meeting your target factor of safety, it's not mean that the solution is wrong, but it is something like your input, it is not meeting. That's it. So you can just click this prescribe the ultimate level of sum of factor of safety. It is not reached it. So that means I assume that my problem, it has to minimum, it has to satisfy around like 1.8, but it is not satisfying because of some issues. It is satisfying up to like only 1.391. Okay. Suppose if I just put it as 1.2 here, because it's satisfying up to like 1.391, I'll just put it as only a 1.2. And then now I'm just trying to solve this. Maybe the here, I just kept it as like 0.1, which is wrong value. Just for my reference also it will be there.
But you are changing in the incremental multiplier, na? Not in target sum.
Is that clear? I'm changing in that. Okay. 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 In the
You are
image wise,
changing in incremental. Yeah, you should change in that
the,
target sum.
yeah, yeah. In the image wise, I'm wrong actually. Okay, fine. In software, I'm doing the right thing. Okay, it's in the target sum itself, like 1.2. Now it says that like 1.2 it is already reached, and it will show you only 1.2 because it's satisfying it. But what is the maximum that if you would like to know, then in that particular cases, you have to do it as like incremental multipliers. Okay. So that was about the consolidation part and as well as the safety factor analysis. So I think I recommend you just to work on this. Sorry, Flaxes 3D and undrained and embankment conditions and all. Hope we have done for this. But if you have any doubts, please reopen it again and then let me know. And with this, actually, we have just considered about the consolidation analysis also. Okay, we have done with the consolidation analysis. Next parts and all, I'll just slowly come to that particular part too as well. And now, submerged construction of an excavation, actually. That's where I would like to solve this as a tutorial 3. So this actually what happens, there is a line where the water level is there and I would like to excavate it inside the water itself. That is like submerged excavations that I would like to calculate this. I already covered this particular problem. When you are doing the submerged excavations, I already told you that you have to select this particular soil. And in this particular after selecting this particular, okay, let's me say that during the construction, that you have to select this particular soil, and in this soil that you have to go to this particular water conditions, and in the water conditions that you have to make it as a dry. That means you are removing the dewatering, you are doing it. If you select the air it as a dry conditions, you are simply doing a dewatering. But if you consider this something like a water level is a different things and all, then the water it is there. So by keeping a water, you are excavating it, or with by removing the water, you are excavating it. So you can just try it, those two particular variants and all. So what I do, I will just pass on this also. The complete informations. Sorry, yeah. The complete informations I will be updating in this. So you can just have a look. The number is like 174. Okay, you can just have a look, or else you can just simply go. If you are not interested onto the boards, you can just simply go here like download access documents. And if you just go to this, and here you can able to see this. So where the documentation, in this you can see the tutorials. In the tutorials, you can see the Flax story tutorials. So in the Plaxis 2D tutorials, you can see submerged construction of an excavation. If you just click on this thing, so you're going to get this. This is the problem statement. You have it. Okay. So you have a sand, you have a clay, and this is the dimensions of it, and the water level also it has been given. It is a fully submerged condition, so the water is fully up to the groundwater level, or maybe up to this particular level. Actually, the water is there, and there is a strut actually. So now you are applying some kind of a load in both the sides, and then you are trying to do these particular things, and you are constructing some kind of a diaphragm walls also. So in this particular problem, that what we are going to learn, we are just going to learn some extra some extra structural elements that we were involving in this. So in this actually we were just adding some kind of another structural elements that we were adding it. So the structural elements are something like the diaphragm walls and to the strut and what is the material properties of all these things. So if you would like to know in detail about this particular things, you can just simply Fluxus 2D 2018 it is there, okay, or else you can just go with some 21 also. You can then just able to open this particular thing somewhere. Okay, so it's a PDF file that you can just do this, or the 23 PDF instructions also you can able to take this things. Okay, the problem is same that you just follow this particular instructions. I'm just downloading the same thing over here and I'm just giving you the links. So you can just directly download it from here. Who got confused of entering into the boards and look into it, who is comfortable by entering into the boards also, that you guys can able to download this particular file from this particular link, and who have like more confusions, I can just give you this also. Okay, I'm just doing it. Please try to do it on your own and come back in the next class anyways that we are going to cover this. But before that also, I would like to encourage you to please go through it once and then you can come back it. Classes. Classes. Yeah, we can start doing this here also. I'm just enclosing with the same. Yeah. Um, yeah, this also I would like to discuss on this. So if you just consider this, it is not mean that all the time that we need to consider the dilatancy angle is taken as a zero condition. Okay, if you have the latency angle, you just provide the value because that gives you the very best plasticity conditions. If you are not providing the latency values, that will not give you the best plasticity calculations and all. But if you have it, you can just. Apart from this, all the points are good. Bharat. But they are meant only for a particular problem oriented, not for all the problem things. Okay, let's start doing this. So for 174 is the number. So you can just look into this. But if you would like to access this also, I encourage to access this and put your comments over there. So I can just give you this link to access. Okay, yeah. So, yeah, Bharat, tell me.
Suppose over footing, I have applied a prescribed displacement of 50 mm.
Uh-huh.
Um, what about that footing load? It includes that footing load.
See, you are only providing you the input of like 50 mm. What is
Yeah,
that particular 50 mm? You can say that.
the displacement.
Displacement of what?
Displacement. of footing. Actually, in our previous sessions, we have directly applied that
No, you
displacement
forgot
over
about the
soil.
previous sessions. Forget about the previous sessions. I want you
Okay,
to understand what is the 50 mm.
okay.
Realistically, you can tell me what is that 50 mm.
Suppose that even after applying load, that footing will settle. I want to restrict the settlement for 50 mm.
Okay. Now you only answer to your question, right?
Yeah.
What is your question? Also, you can repeat it again.
Okay, okay.
Did that clear? I
Ah,
mean, you
yes,
have
yes.
some little confusion. Is that clear now?
Yeah, yeah, yeah. Clear.
Okay. So when you are giving displacement as an input, you are calculating force as an output. When you are giving force as an input, you are calculating displacement as an output. That's it.
Okay.
If we apply the prescribed displacement, like Bharat said, and
Mm-hmm.
run a safety analysis,
Mm-hmm.
then it will give us the ultimate or safe bearing capacities, na?
Yes.
Hmm.
టెక్నాలజీ అప్పుడు డెలైట్కి వచ్చింది చూపు.
Clear? Is that clear, or you want any more explanation on that? Don't keep any confusions with you. Maybe try to repeat your question multiple times so that even I'll also understand your intentions. What you guys are thinking exactly. Cool. Then I'm just stop recording this.